In this video, we will see that how we can solve a linear algebra using the numpy library that is available for Python. In the previous video, we have already seen that how to use the matrix operation, different matrix operations. So here I have just taken an example. So to save time, I already have the written the equation here. So let's consider I have this equation, three set of equations are there, and we need to find the value of x, y, z using the numpy array. Fine. So before that, before I start solving or writing the program, we need to know and do some assumptions. What are those? So first we have to consider the matrix in a equation form, that is Ax equals to B. So you have to imagine that Ax equals to B, and then what you have to do? So just assume that A is the coefficient matrix. Coefficient matrix means what? The constant behind the variables, that is the 2, 3, -1 here, then 4, 2, all these are coefficients. So A is the coefficient matrix, or we can say the coefficient vector as well. So I have to write a matrix A whose value are only the coefficients. Next is X is the column of the all the variables. So X will be used later to solve it. Then B is the so here B is the column vector. So column vector means what? B is the one column of all the constant, that means 8, 10 and 6. So let's write the program directly. So first what you have to do, as you are going to work with the numpy, so I have to import the library here. So import numpy as np. Fine. Okay. Next what we are going to do, we are going to declare the matrix. So which matrix? One is A matrix, one is B matrix, or one is the your constant matrix. So A, I'll write A equals to, how to declare a matrix? So we have to write np dot array inside a bracket. Then I have to use one more square bracket that will create my matrix there, and inside that each row will represented as a separate square matrix. So I'll write one more square matrix here, and then here I'll write the first coefficients, that is 2, 3 and -1. So 2, 3, -1. Okay. So this is one row. Second row, how I have to write? Just give a comma and space, hit a enter. You may or may not use the enter, but if you use a enter, it is easy to visualize. So again I have to take one more square bracket here, and for the second row, those matrix coefficients are 4, 2 and 2. So here will write 4, 2, 2. Fine. So after that, one more comma here, and then I have to create one more row there. So for that I'll write 1, -1, 3. So here I have created my A matrix here. Next I have to create the B matrix. So I'll write B equals to what? What is the matrix? 8, 10 and 6. So this is one column just. So I'll write np dot array, and inside that I'll just give one square bracket here, and inside that I'll write 8, 10 and 6. Now it will be, sorry, 6. Here it will be only one column now. So 3 rows will be there and one column. Remember, inside a matrix, whenever you declare in Python, comma means you are going to a next row. But if you write something inside a square bracket, then you write the comma, that means inside the square bracket it will be considered as a column there. Fine. So this is simple. So next task is I need to solve it. Solve it for what? As we have taken here, x is my solution here, Ax equals to B. So to solve that, just write x equals to np dot linear algebra dot solve. Okay, so we are just going to solve it. We are going to solve for what? Solve for A comma B. So that matrix we have created, the coefficient matrix and the constant matrix, we are going to solve for it. Fine. So if I solve it now, my answer will be done and x value will be calculated. So if I run this code, you can see it is being solved. If I just want to print x, so what it is printing, let us see. So if I just print x here, so it's printing three values here, you can see, but these three values are basically x, y and z. So how do I restore that value? So basically the answer is also a matrix, because x we have taken as column matrix, as I have said here. So this is also in the matrix format. So to get the individual values, what you can do, so I can let me write first value is x underscore value here, and that is equals to x of 0. That means the 0th value, the first value it will take. Fine. So next I'll write y underscore value, so that is equals to x of 1. Fine. Next is z underscore value, so that is equals to x of 2. Fine. Now I have all the three values x, y and z. So I'm just going to write a print statement to print all those values. So I'll use the method of f inverted here. So you'll write x colon, and then the value here, the value is x underscore value. Okay. Then I'll create a new line. Fine. After the new line, I'll take y value here. So y value is what? Y value is y underscore value that we have found there. Okay. And then I'll create a new line again, and I'll write the z value. So z value is your z underscore value. Okay. Now if I run this code, finally I can get the values of x, y and z. So here I have to close this and close this. Okay. So if I run this, now you can see when only I was printing x, it was just printing a matrix for me. But here I have extracted all three values from the x matrix, and then here I am just taking this x, y and z. I am separately I am writing here. So this came as value because I forgot the curly bracket here. Okay. Now you can see x, y and z value have been calculated here. So that's how you can use this numpy library of Python to solve a linear algebra. Next, you can try that instead of initiating these values separately, you can take user input asking that enter the first value or a coefficient, and then you can do the program. So you can try that. If you have any problem, please comment on and I'll try to answer that. So thank you from this video. That's it.